Alright, we're here at gotomath.com working some calculus. Let's go down to the concavity and see what's going on there. I believe I think I've already done all these. I just got to make sure. Yeah, it doesn't look like there's a 9.3. So we're over here at 10.1 then. Okay. What do we got? Find the concavity of the graph. So here's our function. F of x is equal to 1 over x minus 1 squared. Right? So as you can kind of see, we can look at this graph and tell we have concave up, it looks like to 1 here, and then we have concave up again, right? But we want to show this using mathematics, and so let's go to the whiteboard and write this stuff up. We have 1 over x minus 1 quantity squared. Can I remember that? That's the question. F of x is equal to 1 over x minus 1 quantity squared. Right? X minus 1 quantity squared. Okay, looks good. Alright, first thing I'm going to do, since we just have a constant up here in the numerator, I'm going to rewrite this. We might as well just rewrite it right here. Okay, so this is going to end up being x minus 1 raised to the negative 2. Okay, so we don't have to write the 1. There's the 1, but no need writing it. So we just rewrote that. Now we're doing this because there's just a constant in the numerator. So since we're talking about concavity, the first thing we want to do is take the derivative. So we take the negative 2, bring it out front, rewrite, subtracting 1, and of course you always take the derivative of the inside and bring it out, but derivative of x is 1, so we're done. Okay, and then we're going to take the second derivative. So we take negative 3, multiply it by negative 2, you get 6. Subtract 1. And of course, the derivative of the inside, bring it out, but it's just 1. Now, let's rewrite this with positive exponents. That means we're going to take that back down into the denominator. F double prime of x. And of course, the next order of business would be to move this up a little bit, would be to set this thing equal to 0. But as you can see, there are no solutions to this. But since we're looking for concavity, we're going to look at the denominator down here, and it shows here that we do have an asymptote at 1. Okay, so that's what you got to look at. So we're going to do a number line, right, like we always do. Plug that asymptote into the number line. Now let's use a test point. 0 is a good test point, and of course 2 is a good test point. You can choose any number you want to the left of 1 and any number you want to the right of 1, but you might as well choose some easy ones, right? So now what we're going to do is we're going to take f double prime of 0, find out what that is. Now remember, we don't care about the number itself, we just care about its sign, right? If it's a positive or negative number. Okay, so we take 0, plug it in, and since this is to the 4 down here, no matter what this is in here, negative or negative, if it's a negative number, it's raised to the 4th power, it's going to always be a positive number, right? So this is going to always be positive no matter what you plug in for x. So this is positive, positive, and that means concave up. And then of course we plug 2 in, and we get a positive number. Positive. Okay, so we get positive, positive. And I should actually write this. Leave that off, right? So we get a positive number. Okay, so we can say that it's concave up from negative infinity to 1. Union, this is called a union symbol. You're joining both these sets together. And then from 1 to infinity, from 1 to infinity, it's concave up, right? Okay, so that takes care of that. And then we can clearly see that just by looking at the graph. Let's click the answer there. Alright, so looks good, concave up. Alrighty. So you want to come on by, practice that stuff, and maybe you'll chat with me there.